You know, something's been bugging me since the day I started this project a year and a half ago. If you look closely at the CP/M distribution that we're using, and you go into the file system here, and you look at the source code to this file right here, which is an example program that they give us to learn how to use the features of the system, you see this. What the heck is that? Now, if we look closely at this file, we just cat it on the screen. You see it's got this junk here. It's got some junk down there. What up with that, right? Well, let's look more closely at what's in this file. So this is a text file, but this is a CP/M text file, which should be somewhat reminiscent of what you see in DOS, right? Because DOS is basically the same thing. At the end of every text line, you'll see a 0D0A. That's your carriage return and a line feed. I mentioned this before. If you're on a Unix system, you would just see the end of the text line followed by an OA. There is no OD, okay? So we have to be careful if we're going to play with this file on Linux here. We don't screw up these line endings, because then CP/M will get confused. But just so you realize a little bit about what's going on in here. Now, looking at this thing in hex, you can see the ASCII over here, what all the characters and stuff are that are in this file. And if we scroll down near the bottom of this file, you see this section of all E5s right here. Now, I submit that it is these E5s sitting in here that cause the weirdness in that file. If we, what do we do here? Less on Unix here. Go to the bottom here. You can also see the E5s are printed out, and this is what less will do to let you know what's going on. Those are, mostly unprintable or graphic characters and little smiley faces or whatever, right? The end of the file has all these control Z's after it, and this is a CP/M thing that represents the end of a file in an ASCII file. They just pad all their files out with control Z's. And I'll probably have to talk a little bit more about the file system in general. And the interesting thing is that the dump program is how CP/M introduces their file system and how you're supposed to be able to read data from files and access the operating system resources. So it's funny that we have an example program that is corrupted, okay? Now, if we look at this again as a regular old text file, actually less is a little bit friendlier because we can scroll up and down. All right. It's obviously an assembly language source code file. This is designed to be assembled with the CP/M assembler itself. I haven't talked about the CP/M assembler or any of the other actual commands. A little bit of a DDT and a little bit here and there, but we haven't really gone into the details on how to use CP/M to self-host actual code development and stuff like that. And it would be really nice to be able to start with their own example program, which is broken, okay? So let's look at how we can fix this problem, okay? Now, we can do a little bit of forensics here. We know there's just garbage data right in the middle of this file. It probably had some data in here that made sense, that could be assembled and so on, and it's gone. Now, luckily, we also have the executable binary image of this assembled program that is assembled with this assembler up here. If you were to do that on CP/M, of course, as it is right now, it would fail because the file's corrupted. Let's look and see what's in here. Now, down here, it says file dump version 1.4, no input file, blah, 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 blah. This data right here is the stuff that got ruined in the assembler file. if we do less, remember that it says file dump version 1. Look what's at the bottom of this file. File dump version 1.4 $. Then there's a caret. This is going to be like an equate to a carriage return. If we go back to the top of the file, CR, FCB, yeah, there's your 0D, right? Remember I said the end of the lines are all end with 0D, 0A. Well, I'll bet you're going to see a lot of CRs and LFs in this file when they are at the end of printing lines of text. There's just a routine that prints a carriage return, a line feed. Of course, the carriage returns and line feeds that we saw earlier were actually in this text file here. What we're looking at in this text file are the usage of the carriage returns and the line feeds that this program will use in order to print its own messages while it's running. So let's not conflate those two. Color me bad. That's on me. Sorry about that. Okay, so moving on. We need to replace the missing characters in here. All right, now we know some of this is that text message that we just saw. It must be this, okay? No input file present on disk. And then there's some stuff down here. Ooh, we could reverse compile or, disassemble all this stuff. We can bring it up in DDT and ask, hey, what are all these instructions? And, put them back into that file and reconstitute it, okay? But we're incredibly lucky. This file, like I said, is an example file on how to use the operating system features and facilities. And there's a manual that talks about those features and facilities and this file. So if we look closely at the documentation that I put in the retro repo, and we open up our, where are we? Guide, blah, 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 interface guide, right here. I think that's true. If we look at the table of contents in here, a sample random access program, file dump, there it is, right there, page 34. Gol darn, ain't that lucky. If we go down to the end of this file, back up to page 34. Surprise, surprise. I think we're on around there, right? 38. That's another program. This is it right here, I think. I'm going backwards, of course. Here's the dump utility. This is a printed copy of the source code of that file. And if we come down here, come on, where is it? Right there. This is the part of this file that was corrupted. Voila. What are the odds? We can just type these 4 lines back in and recreate the original file in the way that it was supposed to be. All right, now this is in a web browser, so I can just move it over here and kind of keep them both going at once. Well, I never noticed this. Their example here, all lowercase. The actual file, all uppercase. That's weird. So this is not exactly the same, or maybe they just, I don't know, used an editor or something that saved it in all uppercase when they made the file. I don't know. But this is very, very spot checking this. Every little thing is exactly the same except for the file case, right? There's your setup a file, blah, 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 yada, yada. Accum if open error. And he comes down and goes yada, yada, yada. If open error, return. There's a little colon over there, yada, yada. Disk. I'm pretty confident that this is compatible, other than the case, right? So what I'm going to do is I'm going to just edit the file and type this in and fix it. And then we'll have the correct file, right? So let's go ahead and VI this thing. Go to the bottom of the file. Now, normally, I mean, if you actually know me and you actually worked with me, you would know that I actually physically break the caps lock keys off of every keyboard I've ever used, and or go in the operating system settings and disable the caps lock key, because it is so incredibly annoying to have it go on by mistake, because I'm a Vim guy, right? If all of a sudden all your keystrokes are in uppercase when you're in command mode, it ain't a good scene. It really isn't. And this is like the one time that I need caps lock. All right. We'll do it the hard way. I'll hold down the shift key. So I'm actually going to go ahead and just edit this file and type in what's missing. What do we got? Comma, LF, comma, single tick, no. Input. You know what? I'll bet this is uppercase as well. And we have a blank line right here. And then we have a semicolon. And it says variable area. And then we have an IBP DS2. Oops. That says define storage for 2 bytes is what that means. Input. Okay. And then we have old SP. DS2. Then, after that, I'm going to just delete the garbage. Then it says, what? There's like a blank line with a semicolon on the left. And then it says stack area, 164, reserve 32 level stack, blah, 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 and the end. Now, I'm going to delete these Control-Zs down here as well, because it turns out that they'll come back due to the way that the files and stuff are managed with the CPM copy command that we use to build our disk images and stuff like that. All of which we can talk about in another time while actually using this file, by the way. So let's go ahead and look more closely now. All right. We can see that I can't type. Now, my goal is to get it exactly, to the best of our knowledge, the same. And it turns out that the data that was missing can entirely be garbage because of this down here. These are just uninitialized data bytes. Plus this right here. So this is, we got away with a lot on this one. Okay. So, let's run it again. Now it looks pretty good. Now, it'd be nice to know how close we got to the exact number of characters and things like that. All right. So here's our little ODOAs and all this other fun stuff. That all looks good. In other words, Vim did not break this file. Okay. Vim is smart, and it opens up the file and it looks to see, oh, does it have DOS mode line endings, CPM line endings, you know, or whatever, or does it have Unix style? And it maintains it and keeps it the way it is so that we don't screw up these files. Very much unlike, say, Notepad on Windows, where it all of a sudden goes nuts when you open the file and you have the wrong line endings. I think we're all familiar with that. Okay, so how do we then check this? Well, we can do a git status and see that this file has changed. What I'm going to do is I'm going to copy it. There's probably a better way to do this using a git command. Comments, welcome. I know everybody has a chance to learn something. Oops, and not pull. Git checkout this file. Now, what I've done here is I've said, look, I modified this file. I want the original one back. So this is the original one, and this is the hacked one, all right? So if I hex dump minus big C, this X file, and I save it in X dump, and then I do another hex dump, minus big C, dump.asm, save it in, dump. All right. Now, we should be able to use regular old diff now, because those are both printable ASCII files, these .dump files, right? Here's the dump, and then there's this X one here. And this will say, here's the exact bytes that differ. Okay. Obviously, the original one here is filled with all these E5s, starting at hex F80, and the star means repeating this line over and over again until I say otherwise, which, if we look closely again at the original here, it repeats it until it gets to there. Now, by the way, what do you suppose actually happened in here? How did that get there? Out of nowhere, right? Well, keep in mind that E5, as I talked about, many months ago, is the value that's stored on a floppy disk image for each byte that is not initialized. In a blank formatted disk, when it comes out of being formatted, every byte of every sector is set to E5 until you put data on that disk. So what happened here is whoever was making this disk copy, they probably wrote one sector at a time when it was being copied and got a write error here that they did not detect or alert or, didn't notice, right? And then it continued on down here. Because, I say that, first of all, E5s are the values that were put in there, number one. And number two, look at these addresses. F80 is an exact multiple of 128 in decimal, which is 80 in hex. So this is exactly, starts at 80 and is exactly 80 bytes long. That's a sector. And that is exactly what a blank sector looks like. This is a failure of the disk driver that the person used that was making this disk copy, or who read it, or whatever they were doing. That's just a missing sector of data that's been padded. Okay? So let's go back to our diff here. Blank sector starting at F80 and going to FFFF, right? And I just retyped that data. So I replaced all these E5s with exactly this. It's just coincidence that it started with this LF. Okay? ODOA 3B, there's this semicolon right there. Now, the original disk was a 0D, 0A, followed by all these 1As, which is a Control Z character, which marks end of file in CPM. Control Z is undo, right? In like Windows. But on CPM, that means end of file. So the one that I edited with Vim, I remember I deleted all these Control Z's. Maybe I should have left them in there. I don't know. And I just left it end here. So I'm pretty sure I got the exact right character count here. Otherwise, if I would have put too many characters in here, it would have moved, like the semicolon would have been 1 byte later and so on, and it would mess things up in some other way. The fact that actually this is 140, that means that these lines before 140, these two lines here, or actually a couple of lines, these 4 lines here, are not changed in any way, because diff would have noticed that. So I was able to recreate the exact number of missing characters. I copied them from the doc. This is probably correct now, except for the fact that it ends early and it used to have these 1As down here. So I think we are good. We've got some extra junk files in here, but I think I fixed this file. X goes back to dump.asm. Git diff. At the source code, all these E5s are gone. Red, right, means removed, and then the green lines were replaced. And all these Control M's are the carriage return characters that are normally not in a Unix file. So the git diff command is saying, these are weird, because normally I wouldn't expect to see these. So, and they're also part of the differences in the file. So it's really highlighting it to let me know that that happened. So I'm going to go ahead and add this. And there we go. So we're closer and closer to the original thing here. These are some junk files that I'll go ahead and clean up here. Of course, be very careful. You don't delete anything that you want to keep. And now I can just push this back up to the repo. So now we can actually go through the example code walkthrough that they do in this manual here and see how, when you write a program, how you access disk files and things like that in your applications. All right, what do you think? Thanks for watching. I'll see you next time.